Hello friends, continuing with the chapter of communication systems. Today we come to its second part, that is communication systems part 2. In this part we are going to study about antenna. What is an antenna? An antenna is a radiating element or set of elements which radiates electromagnetic waves. It is a metallic conductor having length lambda by 2 erected in space at some height above surface of earth. I repeat, antenna is a radiating element or set of elements which radiates electromagnetic waves. It is a metallic conductor having length lambda by 2 erected in space at some height above surface of earth. Now assignment 15 continues. Question number 8. What should be the length of dipole antenna for carrier waves of frequency 6 into 10 raised to power 8 Hz, second 5 into 10 raised to power 6 Hz? You calculate lambda using the formula C is equal to nu lambda, where C is velocity of light equal to 3 into 10 to the power 8 meter per second and frequency is given to you. Okay, then take half of this wavelength, that will be the length of radiating element. Okay, now height above surface of earth. Now what should be the height of antenna above surface of earth? Let us calculate. Now space waves demand line of sight between transmitting antenna and receiving antenna. Therefore, what should be the height of antenna for transmitting space waves for a particular surface area? And it can be calculated as follows. Now we come to service range. What is service range? Let us define. Service range is the distance from transmitting station to the point up to which signals can be received. I repeat, service range is the distance from transmitting station to the point up to which signals can be received. Here D is equal to PQ is the service range. If you look into the diagram, the D is equal to PQ and is the service range, where at point P we have transmitting station, at point Q we have receiving station. So this distance is service range. Now expression for service range, service area and height of antenna above surface of earth. Let us derive these expressions. Now look at this diagram. Let P be any point at a height h above surface of earth from which space waves, FM or TV signals are to be transmitted. Let the signals be received at point Q at a distance d from transmitter such that PQ is equal to D is equal to service range. Now consider right angled triangle OQP. OQP. Here we have OP square is equal to OQ square plus PQ square, where OQ is equal to R and is the radius of earth and PQ is service range D. Now the equation OP square is equal to OQ square plus PQ square. Here we write OP as R plus H. So we write the equation R plus H whole square is equal to R square plus T square, and from this we calculate D square. or d square is equal to r plus h whole square minus r square, or it is equal to r square plus h square plus 2rh minus r square, where we open the bracket and we get this result, and r square cancels being plus minus. Therefore, we have d square is equal to h square plus 2rh, where h being very small as compared to radius r of earth. Therefore, h square would be more smaller, hence can be neglected in addition. Therefore, service range D is equal to under root h square plus 2rh. I repeat, service range D is equal to under root h square plus 2rh. Okay. Therefore, service range D is equal to under root 2rh. Let us mark it as equation 1. Now, let us derive the expression for service area. Service area therefore is pi d square, because signals are received at 360-degree directions from the transmitting station. Therefore, d can be treated as the radius of the circle of service area. Because d square is equal to 2rh, so therefore we write service area pi d square is equal to pi into 2rh, or simply 2 pi rh. Let us mark it as equation 2. Squaring both sides of equation 1, we get d square is equal to 2rh, or therefore height of antenna from this equation we have h is equal to d square by 2r. Let us mark it as equation 3. Okay. So, this way we have service range D is equal to under root 2rh, service area as 2 pi rh, and height above surface of earth is d square by 2r, where d is service range, pi d square is service area, and d square by 2r is height above surface of earth. Now, assignment 15 continues. Question number 9. A TV tower has a height of 400 meter at a given place. Calculate its coverage range if the radius of earth is 6400 kilometer. Question number 10. A TV tower has a height of 150 meter. How much population the TV telecast covers if average population density around the tower is 1000 per kilometer square, given radius of earth is 6.4 into 10 raised to power 6 meters. So, here is the answer. Question number 11. What will be the required height of a TV tower which can cover the population of 60.32 lakhs if average population density around the tower is 1000 per kilometer square, given the radius of earth is 6.4 into 10 raised to power 6 meters. Okay. Now, maximum range in line of sight communication. Since range of communication in LOS mode, that is line of sight mode, depends upon height of transmitting antenna and is given by dt is equal to under root 2 rht, as well as it depends upon height of receiving antenna, which is given by dr is equal to under root 2 rhr here. Now, maximum range in line of sight mode depends upon height of both antennas and is given by the expression d max is equal to dt plus dr, or we can write d max is equal to under root 2 rht plus under root 2 rhr, as is obvious from diagram. You look at this diagram, this is transmitting antenna, this is receiving antenna. This is the range due to transmitting antenna, that is dt, and this is the range due to receiving antenna, that is dr. So d max will be equal to dt plus dr, and we substitute the value of dt and dr. We get d max is equal to under root 2rht plus under root 2rhr. Okay. Now assignment 15 continues. Question number 12. Calculate maximum range of LOS communication when height of transmitting antenna is 90 meter and that of receiving antenna is 100 meter above Earth's surface. Given Earth's radius is equal to 6.4 into 10 raised to power 6 meters. Question number 13. A transmitting antenna at the top of a tower has a height of 32 meter and the height of receiving antenna is 50 meter. What is maximum distance between them for satisfactory communication in LOS mode? Given radius of Earth is 6.4 into 10 raised to power 6 meters. Question number 14. If the sum of heights of transmitting antenna and receiving antenna in LOS mode of communication is fixed at h, show that the range of communication is maximum when the two antenna have a height of h by 2 each. Now we come to satellite communication. A geostationary satellite containing transmitter and receiver is launched in space, which co-rotates with a point on surface of Earth. It contains a transmitter and receiver which act just as a relaying station. Such arrangement is known as satellite communication system. Look at this diagram. Here we have, this is satellite which contains a receiver as well as transmitter, and here on the Earth we have, this is transmitting station and this is receiving station. Transmitter sends a signal to satellite and it is picked up by the satellite, which retransmit towards receiving end. Because transmitter and receiver, they do not see each other, so therefore we indirectly make them to see through satellite. Okay. So such an arrangement is known as satellite communication system. Thank you so much. Next time we'll take up communication system part 3, where we are going to study about some basic definitions and systems of communications. Till then, goodbye and good luck to you.